In this sample problem, we're given a pedigree and we're told that it's for the condition PKU, phenylketonuria. We're asked, how do we know that individual 3-1 is a heterozygote? So we're not told what type of inheritance is going on in this particular pedigree. We do have our generations, though. We have generation 1, generation 2, generation 3, and down at the bottom we have generation 4. And the individual that we're interested in is individual 3-1. So the first individual in generation 3. We're not told the inheritance pattern for this particular pedigree, but we can actually figure it out pretty easily. We know right off the bat this cannot be a dominant inheritance pattern. And the reason that it cannot be dominant is that dominant traits have to get passed down from parent to child. And what we see is that this particular trait is skipping generations. It shows up in generation 1 and then it skips all the way to generation 4 before it manifests again. So we know this is some sort of recessive. What type of recessive, though? Is this autosomal or is it sex-linked? Well, this is going to have to be autosomal. And the reason that I say that is actually looking at the individual that's important here. Individual 3-1. He does not have the trait. If this were sex-linked, his daughter, individual 4-1, could not also have the trait if he doesn't have the trait and it's sex-linked. Because if it were sex-linked, he would have to pass on his Y chromosome to his daughter, or his X chromosome to his daughter. He can't pass on his Y chromosome. If it were sex-linked, he'd have to have the dominant chromosome here. Excuse me. So no matter what, he would have to pass that on to his daughter. There's no way that the daughter could have the recessive phenotype. She would have to have the dominant phenotype. Since that's not possible under sex linkage, we know that instead this has to be an autosomal trait. That individual 3-1 has to be big A, little a, and then his daughter and his son are both little a, little a. Then he has another child who has the dominant phenotype, but we can't be sure without knowing what his children look like if he's a heterozygote or homozygote. Individual 3-2, the wife, would also have to be a heterozygote. So the way that I can tell this easily is when I do my pedigree analysis, always what I'm going to start with is I'm always going to start with the recessive genotypes. Since I've determined, hey, this must be autosomal recessive, that means that all 3 individuals who are shaded in have to be little a, little a. In order for you to get little a, little a's, you have to have the recessive allele in the previous generation. So we can start building our way up. And we also know that individual 1-1 has to pass on little a to both of her children. So we can't fill in every single part of this pedigree. There are some individuals that remain unknown, but we can definitely determine that both of these individuals have to be heterozygotes, individual 3-1 and 3-2, because they have homozygous recessive children.